Hey guys, Mr. B here. In this video, we're going to be going over the practice problems in the chapter 18.1 notes on what causes climate. All right, starting with number 1, it says what factors what factors affect temperature? So let's take a look here. And I do not need a text box. So, all right. So there are 4 factors that they mentioned in the notes that affect temperature. The first one was latitude. This is how far north or south from the equator you are. Okay, so latitude is 1. How far north or south from the equator you are. 2 was altitude. So this is how high up in the air you are. Okay, so whether you're top of a mountain or bottom of a valley. Number 3 was near large bodies of water, such as oceans or lakes. Okay, and then the last one was ocean currents. Okay, so the last 2, I guess, near bodies of water and ocean currents are very similar, obviously, but these are the 4 factors. So, all right, number 2, how does temperature vary in Earth's temperature zones? So there were 3 temperature zones. Okay, we had the tropical zone, the temperate zone, and the polar zone. So how does temperature vary in each one of those? So the tropical zone has warm and sunny climate with hot temperatures all year round. Then we have the temperate zone, which has warm summers and cold winters. Lots of variation. And then the polar zones basically is just cold and winter temperatures all year round, right? So we have 3 zones: tropical zone, temperate zone, polar zone. Tropical zone in the middle, very hot all the time. Temperate zone was like where we live here in the US, we get hot temperatures and cold temperatures, and the polar zones, it's basically cold all the time. So all right, number 4. It should be number 3, actually. Misnumbered. All right, let's change this. Number 3, number 4, number 5, 6, 7, and 8. All right, well, good thing I know how to number things, right? All right, number 3. List 3 factors that affect precipitation. Okay, so, again, in the notes, there were 3 things that affected precipitation. If you remember what they were, first one we had was prevailing winds. Okay, so that is where wind moves from one direction to another. Okay, wind moves in a certain direction in a certain location, and it can move water around and heat and stuff like that. We had mountain ranges. Okay, so if you are near mountains, that will affect how much rain you get. Whether you're on the windward side of the mountain, where the wind is moving into the land and it pulls water vapor with it and then drops it down on you, or if you're on the other side of the mountains where you get a rain shadow. And the last thing we had was seasonal winds. Okay, all right, number 4, how do prevailing winds affect the amount of precipitation an area receives? So prevailing winds, again, are where we have air that is moving a certain direction. So prevailing winds can affect the amount of precipitation an area receives by moving water to one location into another location. Okay, so it can either cause rainfall or it can essentially decrease rainfall by pulling water away. So we'll say something along those lines. So we'll say prevailing winds affect the amount of precipitation an area receives by either bringing water vapor and rainfall to the location or carrying water vapor and rain away from the location. Okay, something along those lines. All right, last question, number 5. How does a mountain range in the path of prevailing winds affect precipitation on either side of the mountains? All right, so on the windward side, we have a lot of rainfall, a lot of precipitation, and on the leeward side, or the back side of the mountain, we don't have much rainfall at all. We have a rain shadow. So we'll say on the windward side, let's shift this down to There we go. On the windward side of the mountain, there is a lot of precipitation, whereas on the leeward side of the mountain, there is a rain shadow. All right, something like that. All right, question number 6. What causes the seasons? So the seasons are caused by the tilt of planet Earth. Some people think that we have seasons because there's times of the year when the Earth is closer to the sun and times when it's further away from the sun. And that's not true. Well, actually, it is true that the Earth is closer to the sun and further away from the sun at different times of the year, but that's not the reason why we have seasons. Okay, we have seasons because the planet is tilted and the sun's rays hit at different angles at different times of the year, which then causes the land to heat up more or heat up less depending on how much energy it's getting. So we can say the seasons are caused by the tilt of planet Earth. Number 7, describe how the seasons are related to Earth's orbit around the sun. Okay, so there are times of the year when, of course, the Earth is tilted towards the sun when it orbits around the sun, and there's times of the year when the Earth is tilted away from the sun as it orbits around the sun. And so the side that is pointing towards the sun will get more energy, and therefore it's summer, and the side that is pointing away from the sun will get less energy, and therefore it's winter. So let's say as the Earth orbits around the sun, the tilt of the Earth, there we go, doesn't change. So, okay, doesn't change. So there are times when the top or bottom half of the planet is pointed towards or away from the sun. I'm going to shift this up. There you go. Away from the sun, which results in that location getting more or less sun energy, resulting in summertime or wintertime. Okay, there you go. Try to explain as best we could. All right, last question here. Number 8. It says, how might Earth's climates be different if Earth were not tilted on its axis? Okay, so this is an interesting question. So basically the saying is, if the Earth wasn't tilted, right? So it's tilted like this, but let's say the Earth was straight up and down. How would the climates on Earth be different if it stayed like this the whole time as it went around the sun? So this question is interesting, and I think this is probably what would happen. Now, this is just what I think. Okay, could be wrong here. But if the planet was straight up and down like this, that means that the part that is in the middle, right, the equator, would be hot all the time, all year round. In fact, it would probably be almost too hot to live there, probably. But it's going to be very hot all the time at the equator. And as you go further away from the equator, the temperatures are going to get colder, but they're going to stay that temperature all the time, right? So like here in Minnesota, we have warm summers, cold winters because of how our planet is tilted, right? Well, one, there wouldn't be any seasons, okay? If our planet was straight up and down, there would not be any seasons. And here in Minnesota, we're not exactly close to the equator, okay? We're also not necessarily at the poles, but we're not really close to the equator. So the temperature here in Minnesota, if the planet was straight up and down like this all the time, would on average probably be around like 30-something degrees all the time. Which, I don't know about you, but probably wouldn't be the most fun to live here, right? All the time. So basically we can say that if Earth were not tilted, there would not be any seasons. The temperatures on the planet would stay constant depending on where they were in relation to the equator. Okay, so there wouldn't be any seasons. Temperatures on the planet would pretty much stay the same all the time. And depending on where you are in relation to the equator, whether you're on the equator or further away, it's going to be hot there, cold there all the time. There's no change. So, all right, that is the last question for this section of notes. Hopefully that helps you. And as always, if you have any questions, please feel free to reach out so I can help you personally. All right, guys, that's it. I will see you in the chapter 18.2 video. Bye.